All right, guys, for today's assignment, I'm on a bit of a time crunch for this video, so I've got the answers still up here. I'm just going to go through the work for how I did each problem. So we're supposed to find all of the zeros in the complex number system, and we're also supposed to write the linear factorization of the function. So g is quadratic. I can't factor it. So I'm going to start off by doing quadratic formula. So g of x equals 0 when x equals -8 plus or minus square root of 64 minus 4 times 1 times 3. All of that is over 2 times 1. So then underneath the square root, we get 64 minus 12. So that's the square root of 52. The whole thing's over 2. And then 52 is divisible by 4. It's 4 times 13. So this is going to be -8 plus or minus 2 radical 13 all over 2. And then I have down here, that simplifies to x equals -4 plus or minus radical 13. So remember, you divide here and here. So those are the zeros. And then to write out the linear factorization, I didn't simplify this any, but the linear factorization is whatever zeros you find, it's x minus the first 0 times x minus the next 0, etc. So I just wrote it like that. I could distribute the negatives if I wanted to clean it up. Number 23 is x squared plus 25. I don't need quadratic formula for this. I can just say 0 equals x squared plus 25 when -25 equals x squared. Square root both sides. The square root of -25 is plus or minus 5i. So those are the zeros. And then the linear factorization is just f of x equals x minus 5i, x plus 5i. Make sure that you're writing f of x equals g of x equals. You're not just writing the factored expression. Okay, our next one is something that can be factored. We have a difference of squares here. Now, if we've had this on a speed quiz before, we left this as, well, we might have factored this out a little bit. We would do like 4x squared plus 9, 4x squared minus 9. And it used to be that I would say just expand out the difference of squares. But now that we know about that linear factorization, we know that if we get zeros of 4x squared equals -9, x squared equals -9/4. If I square root that, I get plus or minus, I guess I wrote it down here. I get plus or minus 3i over 2. And if I solve for this one, you would add 9 divided by 4, 9/4 positive. The square root of that is 3 over 2. So those are the zeros. And then as you're writing them, you don't want to write x plus 3i over 2, x minus 3i over 2, x plus 3 over 2, x minus 3 over 2. Because for this one, it's supposed to be, if you were to FOIL it back together, you would get a 16 right here. So you have to make sure that you've got 2 times 2 times 2 times 2, which will get you up to 16x to the 4th. If all of these were x plus 3i over 2, x minus, if all of these were x's, I could rectify that by putting a 16 out in front. I've just got to make sure that whatever f of x I write out here actually would multiply back together to be the original. So just be careful with coefficients is all that I'm saying. Okay, on number 30, this is a trinomial that can factor. We can split x to the 4th into x squared and x squared. The factors of 100 that add to 29 are plus 25 and plus 4. I can solve for the zeros right now. If x squared equals -25, I get plus or minus 5i. And then from x squared plus 4, we get plus or minus 2i. And this linear factorization, I can just write out as x plus 5i, x minus 5i, x plus 2i, x minus 2i, because this is just an x, 1x to the 4th, so all of these will multiply to 1x to the 4th. So you really only have to think about those coefficients out in front. If you have fractions or if you like divide it away, a GCF for some reason. Number 31 is 4 terms, so we're going to factor by grouping for this one. So I begin by factoring an x squared out of the first 2 terms. And then I can factor out a plus 16 from the last 2 terms, which will also give me 3x minus 5. And now there's this GCF. So there's a second round of factoring where you factor out the 3x minus 5 GCF. And if you do that from this term, you'd be left with x squared. From this term, you're left with plus 16. So I can get the zeros, x equals 5/3 and plus or minus 4i. And then I can write out the linear factorization. Now the 3x minus 5 was built into the equation, but again, if I wrote x minus 5/3, I would need to make sure that I put a 3 out in front so that if I were to FOIL the whole thing together, I would get 3x to the third with all the other coefficients as well. Okay, and then we're switching gears for number 48. This time we're given zeros, so we're told that a function has zeros 3 and 4i. And we're supposed to write a function that has those zeros. So there are multiple answers here because of coefficients. You could choose to multiply any coefficient times your final answer, but I want to show you how I got here. So first of all, remember, if you're given an imaginary zero, it has to be true that the conjugate is also a zero. So it's impossible for just 4i to be 0. It's really plus or minus 4i. So begin this way. I called mine h of x. You have to make it something. Y equals f of x equals whatever. And then if 3 is a factor, then x minus, if 3 is a 0, then x minus 3 is a factor. If 4i and plus or minus 4i is a 0, square both sides, you get negative 16 because you're squaring 4 and squaring I. Negative 16 equals x squared. So that means x squared plus 16 was one of the factors to give you those zeros. And then I just FOILed this together. So I was just doing like x times x squared, x times 16, negative 3 times x squared, and negative 3 times 16. And then I just put things in standard form. All right, same thing for 50, although instead of just a monomial imaginary number, you're given this binomial. So the same thing's true. Plus or minus, 3 plus or minus 2i are really the zeros here. So when I start building this thing, x plus 1 is a factor, x plus 5 is a factor, x minus, I'm just going to make it 3 plus 2i, and x minus 3 minus 2i. And then there's a trick here to save you. I did this in the notes. There's a trick to save you from multiplying this entire trinomial all the way through to this trinomial. It can get confusing with the i's and stuff. So just rearrange some parentheses for a minute. You can do that via the associative property. If we distribute this negative, I can group together and say, what about x minus 3? This would become minus 2i. So all I've done in that set of parentheses is distribute the negative and just put parentheses around the first 2 terms, just so you can see this more clearly. Distribute the negative through the second group and you get x minus 3, let's put parentheses around that, plus 2i. And it might be kind of hard to see, but we have conjugates here. Conjugates are so much easier to multiply together than a trinomial times a trinomial. So when you multiply conjugates, think x plus 5, x minus 5. Hopefully when you see something like this pair of conjugates, you get straight down to x squared minus 25. It's the same idea here. This is going to be x minus 3 squared minus 2i squared. Just like I wrote x squared minus 5 squared for my example up there. And then out here, we've still got x plus 1, x plus 5. Now, the only reason I would take this out of its factored form, by the way, is because I'm assuming if this popped up on our AP exam, we would be looking for a multiple choice answer that's in general form, not factored form. So we need to be able to do this just in case it pops up or if that's what the instructions tell us to do. So anyway, I've FOILed together those. I'm going to square out x minus 3. So x squared minus 6x plus 9 minus 2i. When you square it becomes 4i squared. And we know that minus 4i squared is really plus 4. So really we've got x squared minus 6x plus 13 in here. And now at this point, again, depending on how I am supposed to write my answer based on instructions or multiple choice answers, it didn't specify in the book how far they wanted it. But at this point, you've got to just FOIL through x squared times x squared, x to the fourth, x squared times negative 6x, negative 6x cubed. So you just kind of have to slog through this. I like to line things up when I can. Like, next thing I'm going to do is take the 6x through. And I just like to line up, like I'm going to get 6x cubed and then minus 36x squared. I just like doing this when I notice that it's not bad to do. 6 times 13, so that's 1878. You could do 6 times 10 plus 6 times 3, 60 plus 1878x. And then take the 5 through, so plus 5x squared minus 30x. Let's do that for here. 5 times 10 is 50 plus 5 times 3. 50 plus 15, 65. And then when you combine terms, hopefully you get what I got for that final answer. Okay, for number 53, it's like 48 and 50, but one more detail. We did this in our notes. You've also got to make sure that you can satisfy the point 1/8, or f of 1 is equal to 8. So we're going to have a degree 4 polynomial. We're given 3 of the zeros. Remember, I really means plus or minus I. That means the factors must have been x plus 1, x minus 2, and if plus or minus I is a 0, that came from x squared plus 1. Or if that's confusing, remember you can always do this. Set x equal to your 0, square both sides, plus or minus negative x squared equals plus or minus negative 1. No, sorry, the plus or minus wouldn't be there. You squared both sides. X squared equals negative 1. X squared plus 1 is the factor. Okay, and then I from here, instead of starting to work on foiling this all together, I like to put in the initial, I like to put in this condition now. So 8 is the y value. Oh, and sorry, there's one more thing. There's some coefficient a, and we don't know what it is. That's the whole point of this. This f of 1 equals 8, because if I were to put in 1 right now, I wouldn't get 8 without an a value here for f of x. So 8 equals some a times put in 1 for x. So 1 plus 1 is 2. 1 minus 2 is negative 1. 1 squared plus 1 is 2. Negative 4a equals 8. So a equals negative 2. And then again, if we're trying to get to general form like this, then I have some more work to do. I now know that a is negative 2. And I can go ahead and FOIL together x plus 1, x minus 2. And then I'm going to have to multiply that by x squared plus 1. And then I take the negative 2 through at the very end. So take the x squared through first, x to the fourth plus x squared, then minus x cubed minus x minus 2x squared minus 2. Combine terms and distribute. So negative 2x to the fourth. There's only a single x cubed, so positive 2x cubed. I've got 1x squared minus 2x squared, so negative x squared times negative 2 is plus 2x squared. Minus x times negative 2 is plus 2x. Negative 2 times negative 2 is plus 4. So that's the general form. If I plug negative 1 into that, I should get 8, hopefully, and also would have these zeros. Number 63, the directions here said find all of the zeros. You're given one of the zeros of the function. You're supposed to find the rest. So again, if 5 plus 2i is a factor, that means 5 minus 2i is also I said factor, I meant 0. And so given the zeros, 5 plus or minus 2i, remember this can help you find the factors. So the factors, you could work on them like this. This is another way I thought to show like how to square out these factors. You could square both sides at this point and work from there. But before we get to that, I want to say, okay, the factors would be, this is the same trick I did in number 50. X minus one of the zeros, 5 plus 2i. X minus one of the other zeros. I want to get this to a polynomial that these have to be factors, meaning they have to divide nicely into g of x. I want to get this into a polynomial, it'll be quadratic, that I can divide into g of x, and then whatever's left will help me find my last zero. So again, you can look at these, distribute the negative, and then look at this as x minus 5 minus 2i times x minus 5 plus 2i. So that when you FOIL these together, these are conjugates, and you can say, oh, that's just x minus 5 squared minus 2i squared. This is x squared minus 10x plus 25 minus 4i squared, which is really plus 4. So I've got this all the way down to x squared minus 10x plus 29. That's a factor. So g of x equals that times something. And to figure out the something, to get up to x to the third minus 7x squared minus x plus 87, we can just do long division. So long division, looks like I've taken up more room doing this problem than I did the first time around. Long division should be short because we're saying we're going to divide x squared minus 10x plus 29. We're dividing that into a cubic, so it's going to be like a one-step thing. X cubed minus 7x squared minus x plus 87. All right, so remember this process. X squared gets multiplied by x to get x cubed, and then multiply that through. And then subtract that whole quantity. Negative 7 plus 10 is 3x squared. Negative x minus 29x is minus 30x plus 87. We multiply x squared by plus 3 to get this, and I just want to make sure it works out correctly. So multiply the 3 through. 3x squared minus 30x. 3 times 29, so 3 times 20 is 60. 9 times 3 is 27. 60 plus 27 is 87. Okay, so this mystery thing was, oh, g of x is that quadratic I got when I squared the two factors, or when I multiplied the two factors together, times x plus 3. And that tells me that the other missing zero besides the one they gave me and the conjugate is x equals negative 3. 67, we're supposed to use a calculator to find the first zero because it's not factorable and they don't give us the first one. So I've typed this into my y equals. I'm going to go to Zoom, just Zoom 6. Usually the zeros they give you are fairly small. It looks like 1 and 2 are zeros. So if I go to second graph, yeah, 1 is a 0 and so is 2. So I'm just going to say that I got these from my calculator. X equals 1 and 2. And I'm going to box those in because those are two of the answers right now. There should be two other answers because this is degree 4. We should have exactly 4 complex zeros. So you can either FOIL the factors x minus 1, x minus 2 together, and then do what we did in 63, get some quadratic that you then do long division with. Or, like we did in our notes, you can take these separately and do synthetic division in any order. So I chose to pick 1 first. I kind of like synthetic division. I find it to be a little bit faster. So we run through our synthetic division. And remember, it should be that we get 0 in the remainder position. Remember that synthetic division, you don't have to label these, but we've just divided f of x by x minus 1. We got down to this cubic. So now we're going to take this cubic and divide it by x minus 2. So we're going to put a 2 out here. Ignoring the remainder part, we're going to put the coefficients for this cubic and do synthetic division. Should get 0 again. You just divided a cubic by an x minus 2, so that should knock you down to a quadratic. And we can solve any quadratic because we have quadratic formula. So for the zeros, we want to figure out when is x squared plus 6x plus 11 equal to 0? When x equals negative 6 plus or minus the square root of 36 minus 4 times 1 times 11 all over 2 times 1. 36 minus 44 is a difference of 8. This is going to be negative, though. Negative 6 plus or minus the square root of negative 8 all over 2. That's negative 6 plus or minus 2i radical 2 all over 2. Divide negative 6 by 2 and 2i by 2, and that's where I got negative 3 plus or minus I radical 2. Don't forget to also list the 2 that came from the calculator. Okay, final